we are doing section 2.1, which is all about quadratics. There are 4 questions on your quick quiz, and as always, those answers are at the end of the section 2.1 notes. And if you're not sure how to do them, you can always come to the math lab and see me or a tutor or whatever. So let's start on our actual notes about quadratic functions. So a quadratic function defined by f of x equals ax squared plus bx plus c, where a is not equal to 0, is called a quadratic function. In standard form. Okay, so we're going to learn 2 forms of quadratic functions. You have your standard form here, f of x equals ax squared plus bx plus c. But then we also have vertex form. So your next bullet point says quadratic functions can also be written in vertex form as f of x equals a times x minus h squared plus k. Okay, so those are the 2 forms we'll focus on today. I tell you this all the time, but math people aren't creative. It's called vertex form because when you look at it, you can see the vertex. That's why it's called vertex form, because when you look at it, you can see the vertex. So the graph of f is a parabola. So every quadratic function has a parabola graph. So the graph of f is a parabola with vertex hk. So I want you to look here for me real quick. This is the vertex, h comma k, the coordinate point. But do you notice how in the function here, it's negative h and k? Y'all see that, or minus h? So here's what we say. When you're pulling the function, when you're pulling the vertex from the function, you always want to, you ready? Change the sign of h and keep the sign of k. So we want to change the sign of h and keep the sign of k. That's why when looking at the function, it's minus h and k. And here we have regular h or positive h and k. But again, we'll see that a little more in a minute. So that's your vertex. Okay, if a is greater than 0, that means if a is positive, the parabola opens upward. And then if a is less than 0, meaning a is negative, then the parabola opens downward. Now, the axis of symmetry is this sort of invisible folding line that you see right here. It means that the graph of the parabola is a mirror image on each side of that folding line. Or you could think of it as if you folded the paper over that line, the parabola would match up on both sides. However, the axis of symmetry is very easy to find because it's always just x equals h, which an easier way to remember that, quite frankly, is that it's just x equals the x value of the vertex. Again, it's just x equals the x value of the vertex. So you can see here your parabola can open upward or it can open downward. Regardless, you have that imaginary folding line called the axis of symmetry. And you also have a vertex. Now, the difference is that that vertex can be a minimum point, a bottommost point, if your parabola faces upward, or that vertex can be a maximum point if your parabola faces downward. And believe it or not, this is almost all of the notes for this section. Now we're just doing problems. And they're a lot easier than you think. It's just a lot of steps. So I'm going to try to make it super understandable, but as always, just stop me if you have questions. Okay, so it says, given f of x equals negative 2 times x minus 1 squared plus 8, complete the following. So first thing I'm going to ask you is, just looking at this, do you think that this quadratic right here was given in vertex form or in standard form? Definitely in vertex. So what I'm going to do is just write the vertex form on top of it. F of x equals a times x minus h squared plus k. Now, what is the value of a? A equals -2. Since that's negative, does our parabola open down or up? That's right. Our parabola opens downward. That's the first question Alex is going to ask you. Does the parabola open upward or downward? Next, it's going to say identify the vertex. But since it was given in vertex form, we can just look at it. We change the sign of h and keep the sign of k. So what do you think my vertex is?
1, 8.
Yeah, that's it. 1, 8. It's just the number that's in the position of h and the number that's in the position of k. All right, now C, we're going to have to do a little bit of work on. C, they've asked us to find the x-intercepts. Now, we've learned this throughout the semester. It does not matter what type of function or equation is given to you. How do we always find x-intercepts?
0.
That's right, by letting y equal 0, which means we take the function itself and set it equal to 0. So -2 times x minus 1 squared plus 8 equals 0. So I'll start by subtracting 8 from both sides. So that would be -2 times x minus 1 squared equals -8. And then I'll divide both sides by -2. So we'll get x minus 1 squared equals 4. And now I've got to get rid of the square. So how do I do that?
Foil.
You could. It would take you longer though. You could FOIL it, subtract the 4 over and try to factor, but it would take forever. What's square root? Yeah, just take the square root of both sides. Now, the only thing you have to remember about taking the square root of both sides is that you always have to put the plus or minus in front of that numerical side. Okay, so over here on the left, the square and the square root cancel, and I'm just left with x minus 1. And then that's x minus 1 equals plus or minus 2, since 2 is the square root of 4. Okay, I'm just going to check over here, make sure we are still good. We are. Every once in a while, if no one else is in the call, it'll kick me out of the call, so I'll check every few minutes. All right, so here we go. We have x minus 1 equals -2, and x minus 1 equals +2. Since we have x minus 1 equals plus or minus 2, we just break that into 2 equations. Then in each baby equation, we add 1 to both sides. So -2 plus 1 is -1, and 2 plus 1 is 3. So it looks like my x-intercepts are -1 and 3, but I will tell you I went through and did it in Alex so I could give you hints. And they are going to ask for those x-intercepts in like coordinate points. So as for putting in your answer, you'll write -1, 0 and 3, 0. Okay, y-intercept. Anytime we find the y-intercept, what do we let equal 0? Yeah, x, good. So we would have y equals -2 times 0 minus 1 squared plus 8. So y equals -2. -1 squared is +1, so that's -2 times 1 plus 8, which is just -2 plus 8. So what is my y-intercept?
6.
6. Good. And they're going to, again, make me put that y-intercept in as a coordinate point. So what would my coordinate point be?
0, 6.
0, 6. Good. All right. Then they're going to ask you to sketch the function. So you'll first have to plot the points, and then you'll click the curve, and it'll draw the curve through those points. When I chose this blank coordinate graph for my notes, it looked better on the computer than it did printed. So my recommendation for you would be to just really quickly highlight your x and y axes. Not that that's part of actually solving the problem, but I just think it'll be easier to graph if you can see those axes a little better. Okay, so we're just going to plot the 4 points that we know. We know our vertex, we know our two x-intercepts, and also the y-intercept. So we'll start with the vertex, 1, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there is our vertex at 1, 8. And then we have x-intercepts at -1, 0 and 3, 0. Except I did that at 2. Man, told you it was hard to see. There we go. Okay. And 1, 2, 3. There we go. That looks better. Okay. And then we also have a y-intercept at 0, 6. All right. And then we're just going to draw the prettiest parabola that we can through those points. Easy enough? Okay. And yeah, this is the easier one. I mean, they'll get harder, but the steps that they ask you to do don't change. Okay, so now we're on F. It says determine the axis of symmetry. So we remember that that's that invisible folding line. But if we go up here, it's always going to be x equals the x value of the vertex. So what is mine? X equals 1. Good. You do have to have the x equals part because it is a line, so you need the equation aspect of it, but it is just x equals 1. Now, based on the fact that our parabola is facing downward, do we have a maximum value or a minimum value? Max. So for part G, the first thing you would select on the computer is maximum. And then you have to tell them what the maximum point is. But the thing is, your max or min is always just the y value of your vertex. So the axis of symmetry is the x value of your vertex, whereas the max or min is the y value of your vertex. So our max would just be 8. So you'd like select max and then type in 8. Easy enough? Yeah. All right, and then domain and range. Now, please, for mercy's sake, on this whole homework, do not get any of the domains wrong because they're all the same. The domain of every parabola ever is -infinity to infinity, and it will never change. Now, range is not quite that easy, but it's pretty easy. If your parabola is facing downward, like this one, your range is always going to be -infinity to that maximum point that you told me a second ago. So what was that maximum point? 8. So because it's facing downward and the arrows are going to -infinity, it's going. Okay, so video cut out. So for the last minute of my online people that didn't get it, here's everything you need. You can pause the video. But if you missed any explanation, I'm going to talk about the exact same thing here. Okay, so let's do another one. Same A through H, just a new function. It says given g of x equals x plus 2 squared minus 1, complete the following. Okay, so this is still the same thing. This is still a vertex. So g of x equals a times x minus h squared plus k. Now, what do you think the a value is this time? 1. Yeah, because it's understood to be there. But 1 is still positive. So does my parabola open upward or downward? That's right. Okay, identify the vertex. That's h comma k. Change the sign of h, keep the sign of k. What do you think? -2, -1. Yep. Okay, C. Determine the x-intercepts. All right. See, x-intercepts are always found by letting y equal 0. So we set the function equal to 0, x plus 2 squared minus 1 equals 0. Okay, adding the 1 to both sides, we have x plus 2 squared equals 1. And what am I going to tell you to do to both sides? Yep. All right, so we have Oops, we don't need plus or minus on both sides. We just need plus or minus on the numerical side. Sorry about that. There we go. So over here, the square and the square root cancel. So we have x plus 2 equals, and what is the square root of 1?
1.
That's right. So x plus 2 equals plus or minus 1. So what am I going to tell you to do next? Split it. Yeah, break it into 2 equations. So we have x plus 2 equals negative 1, and we have x plus 2 equals positive 1. And then we'll subtract 2 from both sides in both of those equations. So negative 1 minus 2 is negative 3, and 1 minus 2 is negative 1. So we have x-intercepts of negative 3 and negative 1. So I'm going to write those up here as coordinate points. So negative 3, 0, and negative 1, 0. Okay. D is the y-intercept, which is where we let x equal 0. So y equals 0 plus 2 squared minus 1. 0 plus 2 is 2, and 2 squared is 4. 4 minus 1 is 3. Okay, so we have a y-intercept at 0, 3. All right, any questions so far? Okay, put those points on your graph. It's up to you, but I'm going to highlight my x and y axes again. It's my x, and there's my y. So again, you're just plotting those points and drawing the prettiest parabola you can through them. So I've got negative 2, negative 1 as my vertex. Then I have negative, let's see, didn't quite go far enough over on that. It's hard to see on this screen. Here we go, negative 2, negative 1, I apologize. Then we have negative 3, 0, and negative 1, 0. And then we also have 0, 1, 2, 3. Okay, so prettiest parabola we can through that. And there we have it. All right. Any questions so far? Okay, what's my axis of symmetry?
H2.
Good, but what do I have to have in front of it? X equals.
Okay.
Because you got it's a
Do we
line.
have to write that?
It's
Okay.
gonna make you type it. Well, they may have like X equals and then a box, but if they don't have it, I'm almost certain you have to write X equals negative 2. Okay. Based on the way this parabola is facing, does it have a maximum value or a minimum value? Minimum. And what is the y value of that minimum? Negative 1. Good. Again, axis of symmetry is always the x value of your vertex, and then the maximum or minimum is the y value of your vertex. Okay. What is the domain of every parabola ever? That's right. In this section, that will always be your domain because this section is all about quadratics. Every parabola has a domain of negative infinity to infinity. Okay, now this time our parabola is not facing down. So we're not going to do negative infinity to the minimum. Instead, to the maximum, excuse me. Instead, we're going to do the minimum number to infinity. So what did you tell me the minimum number was for this parabola? That's right. So it gets a bracket because we actually hit that value of negative 1. And then we go up to infinity. So negative 1 to infinity. Okay, still good? All right, does everybody have what they need? Sweet. Okay, now the thing is, it's really easy to calculate all of this stuff when it's given to you in vertex form, but it's not always going to be given to you in vertex form. So now we're going to learn how to find the vertex of a parabola if it's given to you in general form, which is f of x equals ax squared plus bx plus c. But it's super easy, okay? If your vertex is hk, or XY. Okay, either way, this is your vertex. Then the H value or the X value, same thing, is found by calculating negative B over 2A. So if you're looking for the X or H value of your vertex, you calculate negative B over 2A. If you're looking for the K or Y value of your vertex, you're going to take that number you got at first and plug it back into the function, f of negative B over 2A. Now, when we write that out as a formula, it looks way more complicated than it actually is. So that's why we're going to do example 3 together. I just gave you 3 different functions, all given in standard form, and we're going to find the vertex of each one using these formulas. All good? Okay. Here's A. We have f of x is equal to x squared plus 8x plus 7. And we're going to find the vertex of that quadratic function. So first you have to tell me what A, B, and C are. What's A? 1. Good. What's B? 8. Good. And 7 is C. Excellent. Which we don't really need the C because, as you can see, the C is not in the formula, but I think it's important for us to practice writing it. So to get the X or H value of our vertex, we're going to calculate negative B over 2A. So that is negative 8 over 2 times 1, which is negative 8 over 2. So what is that? Negative 4. Now, how am I going to get the Y value of my vertex? That's all you do. It's really that simple. You just take the value that you just got, which in this case was negative 4, and plug it back into the function. So this is negative 4 squared plus 8 times negative 4 plus 7. Okay, so negative 4 squared plus 8 times negative 4 plus 7, and I got negative 9. So that means my vertex for this f of x function is negative 4, negative 9. All good? Any questions? Okay, let's try another one. Say that one more time, I'm sorry.
Like if we had to draw it,
Mm-hmm.
A being 1 means it's got to open up.
You're absolutely right. And that's really important to understand because you know how both the vertex form and the standard form have A's? Like the A is in the front of the parentheses in the vertex form and the A is just on the x squared in the standard form. That A value is the same. So as long as A is positive, it'll always be up. As long as A is negative, it'll always be down. So you're absolutely correct. Since the A value here was 1 and that's positive, this parabola would have a vertex at negative 4, negative 9 and go up. Yeah, great question.
Are you gonna write it in vertex form?
We will in the next problem. That's a really great question. I'm actually in examples, I think it's 4 and 5. I'm going to show you how to use this formula to change it to vertex form. This one just wants the vertex. Yeah. And you'll have a couple like this where they just give it to you and they just say, what's the vertex? Mm-hmm. Yeah. So that's all they want here, but I am going to show you how to do that in a second. Okay. So B, I wanted to show you this one because it was a fraction. So K of X equals negative 1/3 x squared plus 6x plus 1. So I know y'all know how to do this, so I'm just going to write it. A is negative 1/3, B is 6, and C is 1. Y'all are comfortable with that? Okay. All right, so the x value of my vertex is negative B, which is negative 6. I'll go ahead and write the formula since we're just learning it. Negative B over 2A. So that is negative 6 over 2 times negative 1/3, which looks incredibly complicated to type into the calculator, which is why I wanted to discuss this with you. So I'm going to give you some suggestions. Here's what I would do. You do you, whatever works for you. But here's what I would do. First of all, before I put it in my calculator, instead of writing 2 times -1/3, I would write -2/3. When you multiply a whole number like 2 and a fraction like 1/3, you just multiply the whole number into the numerator. So 2 times 1 is 2. Okay, now that you have it just as -2/3, you're going to enter it into the calculator exactly as you see it written here. So in the calculator, it will quite literally look like -6 and then a division symbol, and then parentheses, -2, another division symbol, 3, close parentheses. That's exactly what that will look like in the calculator. And you get a whole number. So -6 divided by, open parentheses, -2 divided by 3, close. And I got 9. Okay, so that's the X value of my vertex. Y'all okay with putting that in? And how do I find my Y? Yep. So I'm going to find K of 9, just going to plug it in. And I want to talk to you about how to put this in the calculator as well, but let's write it first. So that would be -1/3 times 9 squared plus 6 times 9 plus 1. Now, you're actually going to put it in the calculator exactly as you see it written here. My only suggestion is that you put a set of parentheses, like an extra set of parentheses around the fraction. Anytime you have to put a fraction in the calculator, I always recommend putting a set of parentheses because it just helps ensure that the calculator is doing the order of operations correctly. So like open parentheses, -1 divided by 3, close parentheses, open parentheses 9, close parentheses squared, plus 6 times 9 plus 1, and I get 28. So I guess the vertex for K of X is 9, 28. Okay, all good? Move it up a little bit for my people that are in the back. Any questions? Okay, let's do one more. I know it's a little bit overkill to still do another one, but this one was a little different than the other two because, well, you'll see why in a second. So I just wanted to make sure I taught you how to do it. So the last one we're going to just find the vertex for is G of X equals 2x squared plus 14. Okay. So talk to me about A, B, and C. What is A? 2. What is C? 14. What is B? 0. Good. So A is always the coefficient or the number connected to x squared. B is always the number connected to x, and C is always the number that stands alone or the constant. Since there is no like just an x, we say that there's no B, so we say there's 0, that it's 0. So A is 2, B is 0, C is 14. Y'all good with that? Okay, sweet. So the x value of our vertex is still -b over 2a. So technically that would be -0 over 2 times 2, but we know that 0 doesn't have negative or positive, so we're just going to say that's 0 over 4. But what is 0 divided by anything? 0. Yep, so the x value of my vertex must be 0. To get the y value, I'm going to plug that back in. So I'm going to calculate g of 0, which is 2 times 0 squared plus 14. Of course, that's just 0 plus 14, which is 14. So 0, 14 is my vertex for the last one. And again, just going to scroll down a little bit just so that my people in the back make sure they get all of that. All good? Any questions? Okay, so all of this is saved. So if you miss any of it, don't hesitate to come up after class. I can pull it back up for you and let you take pictures or anything. I think I see everybody finished writing though. All right, let's take a look at example 4. If you'll notice, B through I used to go through H, but look at these right here. These are the exact same questions that were posed to you in 1 and 2. That's the exact same questions. The difference is look at the quadratic function that was given to you. In example 1 and example 2, the quadratic function given to you was given in vertex form. Now it's given in standard form, which is f of x equals ax squared plus bx plus c. Now, the very first thing you've never done before, it says write the function in vertex form. So what I'm going to do is teach you how to write it in vertex form, and then you're going to be able to use that vertex form to answer the rest of the questions just like you did in example 1 and example 2. So I'm going to give myself a little more room. I think you'll have room, but I want to make sure I write it large enough for everybody. So this is how we do example 4a. We are given the function f of x equals 3x squared plus 12x plus 5. And we are asked to take that function in standard form and translate it to vertex form, which is f of x equals a times x minus h squared plus k. Now I'm going to make a recommendation to you. I do not recommend that you do it's not called help me solve this anymore. It's like a guided solution, or I think is what Alex calls it. Yeah. Pearson was help me solve this, but here it's guided solution. The thing is, if you click guided solution, they're going to teach you a really difficult way to do this. They're going to teach you how to do it with something called completing the square, which is fine, but it's literally like, I don't even understand why they teach that here, because it is literally the most difficult way to do this problem. This is easy. You actually already know how to do it. You just got to put the puzzle pieces together. So everybody agrees with me that this right here is vertex form, correct? So I can then make the statement that if I want to write something in vertex form, I need 3 values. I need an A, I need an H, and I need a K. The moment that I have those 3 values, I can plug them in and have the vertex form. Well, right now I have standard form, so I don't have an A, H, and K. What I have instead is an A, a B, and a C. The A is 3, the B is 12, and the C is 5. Everybody with me so far? Now, the A is the same. So if A is 3 in standard form, A is still going to be 3 in vertex form. So you actually already have your A value. You do need your H and your K, but we have a formula for finding H and K. H is found by computing negative B over 2A. We just learned that. So this would be negative 12 over 2 times 3. Which is negative 12 over 6. So what is my H value? Negative 2. Now, what's the only value that I'm still missing to be able to write vertex form? K. All right. But we know how to do that. To find the K, you just take the value you found for H and plug it back into the function. So we're going to evaluate f of negative 2. So 3 times negative 2 squared plus 12 times negative 2. Sorry, started writing the wrong number. Plus 5. And I'm going to type that into my calculator. 3 times negative 2 squared plus 12 times negative 2 plus 5. I got negative 7. Yeah. Okay. As soon as I have an A value, an H value, and a K value, all I'm going to do is plug those values into this formula. So f of x equals, in the place of A, I'm going to put a 3, open parentheses, x minus. In the place of h, I'm going to put a -2, close parentheses squared, and in the place of k, I'm going to put a -7. So this becomes f of x equals 3 times x plus 2 squared minus 7. No need for completing the square or any other fancy method. You just have to find a, h, and k with formulas that you already know, and then plug that a, h, and k back in. Okay, so again, that's f of x equals 3 times x plus 2 squared. I'm trying to see where I have it written here. There it is, minus 7. So I'm going to come over here and write that next to part A. F of x equals 3 times x plus 2 squared minus 7. And now I'm going to complete the rest of this just the same as I did examples 1 and 2. All right, so first question. Determine whether the graph of the parabola opens upward or downward. What's the a value? 3. It's positive 3, so what does it do? If it's positive, it goes upward. Now, use the vertex form to identify the vertex for me. Remember, change the value of h, keep the value of k. -2, -7. Just like we did in examples 1 and 2. Change the value of h. It's positive 2 here. I made it -2 here. Keep the value of k. All right, now let's talk about the x-intercepts. D, determine the x-intercepts. Now, technically, we know that to find the x-intercepts, you let y be 0. What I was going to say, but I was getting ahead of myself, is technically you can set either function equal to 0. Like you can set the original standard form equal to 0, or you can set the vertex form equal to 0. I'm going to do example 4 by setting the standard form equal to 0, and then I'll do 5 by setting the vertex form equal to 0 to show you that you can do either. So I honestly typically recommend doing standard form, and I'm going to show you why. Because, let's look at this. So if we take the standard form of the function, 3x squared plus 12x plus 5 equals 0, you could try to factor that, but it's not going to factor. So in order to solve that, you're going to have to do quadratic formula, which you should have at least seen before, but it was on quick quiz number 4 right here, and you practiced it with these two. But it is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so x equals, that would be -12 plus or minus the square root of 12 squared, which is b squared, minus 4 times a, which is 3, times c, which is 5. And that's all over 2 times a. Okay, have y'all at least seen the quadratic formula before, even if it's been a while? So once I wrote the formula down, y'all know where I'm getting those numbers from, right? And plugging them in. Okay. So now what I like to do, and people do this different ways, but I like to take my calculator and just type in the part underneath the square root. So I'm not typing in the square root at all. I'm just typing 12 squared minus 4 times 3 times 5 to simplify that. And you get the square root of 84. And that's over 6. Okay, now you do need to see if you can simplify the square root of 84. So I'm going to go up here on the side, just do it in a different color. Give me 2 numbers that multiply to give you 84. 4 and 21. Yeah, I think that's pretty much all we can use. 4 times 21. The reason we choose 4 and 21, though, is because I can take the square root of 4. What is the square root of 4? 2. So if I rewrite the square root of 4 as a 2, and then I just carry down the square root of 21, I can say that the square root of 84 simplifies to 2 square root of 21. So this becomes x equals negative 12 plus or minus 2 square root of 21 over 6. So far, so good? Okay. And I promise I'm coming back to your question of why I choose standard. Let me simplify it and then show you something, okay? So the last simplification step is you have to look, let me highlight it. You have to look at these numbers, 12, 2, and 6, the numbers on the outside. Do those numbers have anything in common? Like, are they all divisible by something?
Yes.
By 2, right? So if I divide negative 12 by 2, I get negative 6. If I divide 2 by 2, I get 1. And if I divide 6 by 2, I get 3. So as a final answer for my x-intercepts, and yes, I know this one was difficult on the x-intercepts, you get negative 6 plus or minus the square root of 21 over 3. So when you go to write your x-intercepts, that's going to be negative 6 minus the square root of 21 over 3, comma 0, and negative 6 plus the square root of 21 over 3, comma 0. Okay, so I'm going to give you a second to write that. And while you write that, I'm going to circle back to explain why I would use the standard form instead of the vertex form. Okay, so I'm going to try to position this to where my online folks can see this too, but you don't have to write this down. I just want you to watch. So theoretically, I could do 3 times x plus 2 squared minus 7 equals 0, and I could solve it that way, okay? If I did that, though, I would add 7 to both sides, so I would get 3 times x plus 2 squared equals 7, right? Then I would divide both sides by 3, so I would get x plus 2 squared equals 7/3. Then I would square root both sides, and I would get x plus 2 equals plus or minus the square root of 7/3. And then I would subtract 2 from both sides to get x equals negative 2 plus or minus the square root of 7/3. Now, that looks very different from negative 6 plus or minus the square root of 21 over 3. However, if you were to type them in the calculator, you get the same decimal, which means that the form is different, but they evaluate to the same thing.
So whenever we enter this into the thing or whatever, are we gonna put it in that form or?
Yes. So that's actually what you just said about how you enter it into Alex is why I recommend you doing it with the standard form. Because if you look at this, do you see how this is the square root of 7 over 3? That means this denominator has a square root too. And I don't think it's going to take the answer like that, because I think it's going to tell you that that your denominator isn't rationalized. Does that make sense? So yes, this evaluates to the same thing, even though it looks different. It's the same answer, but I don't think that Alex is going to like this answer because of the 3 with the square root in the denominator. When you do quadratic formula, it automatically sort of takes care of your denominator. There's never a square root in it. And so because of that, this is a more acceptable answer. Does that make sense? So when it comes to this part, this is what you would enter in as your final answer. Now, we do have to have an approximation for graphing. So take your calculator for me, and I want you to type this, negative 6 minus the square root of 21. And then I just want you to press enter. Press enter before you divide by 3. So negative 6 minus the square root of 21. You get like negative 10.58 something. Now divide it by 3, and you get about negative 3.5275 something, I don't know. So we'll say that for graphing purposes, the approximation of this one is negative 3.50. Okay, approximately. Now let's do it again. -6 plus the square root of 21, you get like -1.4 something. Divide that by 3, -0.47. So we'll say it's about -0.5. Again, these are approximations to help us with graphing when we get to step F. Okay, but yes, the x-intercepts are very hard on this one, I know. That's why I took the time to go through them slowly. Before I get to E, which is the y-intercept, do I have any questions that I can answer or help clarify? Yeah, what you got?
How would you graph that? It's gonna ask.
It is. So here's one thing that I love about Alex versus Pearson. So when you go to graph something, it'll tell you you need this many points or whatever. It's going to let you type that point in, and then it's going to graph it for you. So you see the whole approximation thing. I really need that for paper graphing because, like, I don't know where -6 minus the square root of 21 over 3 is. But when it comes to the computer, you won't need the approximation. It's going to actually let you type in the point, and it'll plot the point in that position for you. Even like the like fractions, square roots, but even just the ones that are whole numbers, you just type 30 and it plots the point for you. It's really nice because it's going to tell you you need like 5 points. So you type in or 3 for this one, I think, like, however many points. But then you type in those points, it plots them for you. Then you click the graph and it will just like draw your curve through those points. It's much nicer than what we had to do in Pearson, but that's a good question. Really good question. Anything else? All right, guys, let's tackle this y-intercept. This is your part E, which is where we let x equal 0. Again, you can use either, I'm going to use standard again just because I think it's easier. So we would have y equals 3 times 0 squared plus 12 times 0 plus 5. So of course that's just y equals 5, or the coordinate point 0, 5. Okay, time to sketch the function. I am going to highlight my x-axis so that I can see it better. And I'm going to highlight my y-axis so that I can see it better. And now I'm going to plot those points. So my vertex is at -2, -7. So let's see. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Here we go. I did not mean to make that other little point. Let's see if I can make it go away. All right, there we go. -2, -7. Then I'll plot my approximations. -3.5, so 1, 2, 3.5. And then -0.5 is about here. And then I also have the point 0.5. 1, 2, 3, 4, 5. And I'll draw the prettiest parabola I can through those points. Okay. My axis of symmetry is x equals what here? -2. Good. It's always x equals the x value of your vertex. So for this example, it's x equals -2. And then minimum or maximum here? Minimum. And the minimum is just the y value of my vertex. So what would that be here? -7. You got it. And then I'm going to do domain and range down here just because I have a lot of writing right there. So what is the domain for every parabola that has ever existed? You got it. -infinity to +infinity. Okay. And then the range, this one is facing up, which means I'm going to start with my minimum of -7. It gets a bracket, and I'm going to go up to what? Infinity. You got it. Yep.
Wait, why does it get a bracket?
Because we're touching that point. So you're always going to get a bracket because you're actually hitting that point.
Okay.
Yeah. For all your parabolas, like whether that's your max or min, that number will always get a bracket. Okay. Y'all are asking really good questions. Thank you. My last class was like really, really quiet. They like just looked at me like I was, I don't know, speaking Chinese. I don't know. Do y'all have any other questions? Okay, I just wanted you to take a deep breath because I want you to know that example 4 was the hardest one in the notes. If you got through that, you're fine. It's fine. Just everything else is going to be a breeze, okay? So this is the same thing, but we're not going to have to do quadratic formula this time, okay? It's going to be much easier. It's the same question, no quadratic formula. Okay, so they give me something in standard form. F of x equals negative x squared minus 4x minus 7. Again, the first thing they ask me to do is rewrite it in vertex form. So I'm going to walk you through that process again, just down here. Okay, so the original function they gave me was f of x equals negative x squared minus 4x minus 7. Now I need to change that into vertex form, which is f of x equals a times x minus h squared plus k. What three values do I need to put something in vertex form? A, what else? H and k, very good. Now right now, because I was given the function in standard form, I don't have a, h, and k. I instead have a, b, and c. So what was my a value? -1. What was my b value? -4. Good. And what's my c value? You got it. Now I technically already have a because the a's are the same, so that's still -1. Now h is found by calculating negative b over 2a. So that's -4 over 2 times -1. So that's +4 over -2, which is -2. So I guess my h is -2. And then my k is found by taking that value and plugging it back into the original formula. So I'm going to calculate f of -2. Moving it down a little bit so you guys in the back can see. That would be -2 squared minus 4 times -2 minus 7. So I'll take my calculator. Negative, open parentheses, -2, close parentheses, squared, minus 4 times -2 minus 7. What'd y'all get? -3. Good. Yep. Okay. I have a, h, and k. It happens to be -1, -2, and -3. So I can now write this in vertex form. Okay, remember, I'm just taking this form and filling in the a, h, and k. So -1, open parentheses, x minus, then h is -2, close parentheses, squared, and then I'll put -3 for k. Now, the -1, the 1 is understood, so you really just need the negative. So your final version would be f of x equals negative, open parentheses, x plus 2 squared minus 3. Because again, the 1 is understood, and so we just need the negative on the outside. And of course, this double negative becomes a positive. Okay, so I'm going to come up here. I'm just going to write that in here so that I have it for reference and I don't have to keep scrolling down. So we have f of x equals negative, open parentheses, x plus 2 squared minus 3. Now I'm going to use that and answer b through I the exact same way I did example 1, example 2, and example 4. Identify the vertex. Well, the vertex is hk. Change the sign of h, keep the sign of k. We have -2, -3. Any questions on the vertex? All right, let's find the x-intercepts. Now this time, I'm just going to show you, you would get the same answer either way, but I'm going to show you that you can use the vertex form if you want. So negative, open parentheses, x plus 2 squared minus 3 equals 0. Add 3 to both sides, you get negative, open parentheses, x plus 2 squared equals 3. How would you get that negative off of the front? Yeah, just divide both sides by -1. So divide by -1, divide by -1. Of course, the negatives cancel over here. And you are left with x plus 2 squared equals -3. Now, what am I going to tell you to do at this point? Yes, I am going to tell you to square root both sides, and I'll always tell you to put a plus or minus, plus or minus in front of the numerical side. However, are we allowed to take the square root of a negative? No. So that means that we get no solution. What do you think it means if we get no solution when we're trying to solve for our x-intercepts? We don't have any. That's exactly what it means. Yes. If you get no solution when you're trying to solve for your x-intercepts, then that just means that you don't have any x-intercepts. So in ALEKS, you would just select the button or the drop-down menu or whatever that says no x-intercepts. All good? Okay. So now we're moving on to E, which asks us to find the y-intercept. And we know that that's where we let x equals 0. Okay, so let's see. I'll just you can plug it back into either. I guess we'll keep the same this time and plug it back into the vertex form. So negative, open parentheses, 0 plus 2 squared minus 3. So that's like -4 because 2 squared is 4. So -4 minus 3. So y equals -7. So I guess your y-intercept would be 0, -7. All right, time to sketch that function. Now here's where things get slightly funky, but not nearly as complicated as example 4. Oh, there we go. Save. Okay. All right. So the problem is we normally have at least 4 points to graph our parabola. How many points do I have right now since I have no x-intercepts? 2. I've got -2, -3, which is my vertex point. And then I also have 0, -7, which is here, right? But I need at least one other point to draw a parabola. But that's where this imaginary folding line comes in. Remember, our imaginary folding line is right here through the vertex. That's a folding line. That means on the other side, it's going to match up. So if you have this point right here, you're going to have a mirror image point on the other side of that folding line. So there's your parabola. If you're missing another point, just make a mirror image point. And can you see from the graph that there are no x-intercepts? Easy, right? Okay, what's the axis of symmetry here? X equals what? Yes, I promise I didn't try to pick all examples with -2 as the x value of the vertex. I just did. I don't know. It was not intentional. Okay, does this parabola have a maximum or a minimum? A maximum. Good. And the maximum is the value that is the y value of the vertex. So what is that here? -3. Okay. And tell me what my domain is. -infinity to +infinity. And what is my range?
-infinity to -3.
You got it. -infinity to -3. Any questions? Okay. So what I'm going to do is stop here. We have 2 examples left, but they're not long like the ones we did. We did all the long ones. So when we come back to class after your test, so Thursday of next week, I'll start the lesson with 6 and 7, and then we'll jump into 2-2. Okay?